Hey Warriors, welcome back to week number 9 of SAT preparation and advisory. This week we're taking a look at nonlinear solving. So last week and the week prior, the linear solving chapter provided you with a foundation in the fundamentals of linear solving that are key to improving your math score. In this chapter, you'll review the terms and rules related to nonlinear solving concepts that you will need for the digital SAT. Okay, before we move on, today I want to preview some of the topics: quadratics, factoring, foiling, exponents, the basic rules, special rules, using the calculator to solve nonlinear equations, roots, rationalizing the denominator, combining roots, more calculator practice, working with fractional exponents, working with negative exponents, number of solutions, growth and decay, and strategies. If you have already covered this topic in your math class or your SAT preparation class, you can skip this video and move on to the practice at the end of the lesson today. If you have not seen all of these topics, then I really recommend that you watch the video to get a foundational understanding of each of these principles. Starting with quadratics, let's first take a look at the following equation. X plus 12 is equal to 7x. So you may be able to solve this fairly easily, but if the question were a bit harder, x squared plus 12 is equal to 7x. This would be an example of a quadratic equation. Quadratic equations are equations that can be put in the following form. Ax squared plus bx plus c is equal to 0. The form above is known as the standard form, and this type of equation appears frequently in the digital SAT math section. Fortunately, it is one that you can learn to solve. So these are the two methods that we will use to solve quadratic equations. First, we'll take a look at the method above, which is factoring. Factoring begins with a standard equation, with the standard form of an equation. So in our example, we're still going to practice with x squared minus 7x plus 12 is equal to 0. And then we factor that into two expressions. So we set up x in both and set that equal to 0. Then we need to determine what kind of signs to include in each factor. So this is based on the signs in front of the c term, 12, and the b term, negative 7. If the sign in front of the c term is positive, that means that the signs inside of the factored form will match. So it's either going to be addition in both or subtraction in both. We know which one to use based on the sign in front of the b sign. So here it is a negative sign. That means we're going to plug in negative signs. In order to find the factors, we need to figure out which two numbers can be multiplied to give us a positive 12 and added to give us a negative 7. So here we insert 3 and 4 because 3 and 4 combine to give us 12 and can be added to give us negative 7. Our final step when we are factoring is to set each expression equal to 0 and then solve for x. So here we have x minus 3 is equal to 0, or x minus 4 is equal to 0. Our solutions are then x is equal to 3 or x is equal to 4. 3 and 4 are the solutions or roots of the equation. The second way that we can interact with quadratic equations is through FOILing. This time we are working in reverse. So if we have the factored form, in our example here, it is x plus 5 times x minus 2. We begin by multiplying the first terms, x times x. Then we multiply the outer terms, x times negative 2. Then we multiply the inner terms, 5 times x. Then we multiply the last terms, 5 times negative 2. And finally, we combine like terms to get x plus 5 times x minus 2 is equal to x squared plus 3x minus 10. Next, we will talk about everything exponents. The exponent tells you how many times to multiply something by itself. Whenever the bases are the same, to multiply the quantities, keep the base and add the exponents. To divide the quantities, keep the base and subtract the exponents. To raise the quantity to another power, multiply the exponents. If quantities with the same base and exponent are added or subtracted, just add or subtract the coefficients and do nothing to the base or exponent. When you put all of the exponent rules together, we get the acronym shown here, MAD-SPM. That stands for multiply, add, divide, subtract, power, and multiply. There are also some special rules associated with exponents. That any number to the exponent 0 is 1. Any number to the exponent 1 is itself. 1 to any exponent is 1. 0 to any exponent besides 0 is 0. A negative number raised to an even exponent is positive. A negative number raised to an odd exponent is negative. And a fraction between 0 and 1 raised to a positive exponent gets smaller. So if you are multiplying x to the power of 2 by x to the power of 3, because the bases are the same, you add the exponents straight across to give us x to the power of 5. In example 2, x to the power of 6 divided by x to the power of 2 would leave us with x to the power of 4 because we are simply subtracting the exponents with a similar base. 3, because we are raising an exponent with a base to another power, we have to apply that exponent to everything in parentheses. So we would multiply x to the power of 4 by 2, leaving us with x to the power of 8. In example 5, we would apply this 3 to both the 2 and x to the power of 2. Finally, in example 7, the base x is the same and they are being raised to the same power. So we can combine the constants in these terms, leaving us with 8x to the power of 2. Let's take a quick look at some of the special rules for exponents. For example number 1, x to the power of 5 divided by x to the power of 5 would leave us with x to the power of 0. So our final answer would just be 1. For example 3, x to the power of 1 leaves us with x. For example number 5, 0 to the power of anything besides 0 is still 0. 6 and 7 show us what a base number that is negative looks like when it is raised to an even power and an odd power. In example 6, because it's raised to an even power, this will be positive 4. And for example number 7, because it's an odd power, it will be negative 8. Here's a button that you will see on the digital calculator. There are two options when we are working with exponents. Is a squared. That will square the number, variable, or term that you've entered before pressing that button. If you are squaring an entire term, please put those things in parentheses. That is not the same. Note that in the example, x plus 2 squared is not the same as x plus 2 squared. The second button that you will find useful is a to the power of b. This button takes the first number, variable, or term that you enter and raises it to the power of the second number, variable, or term that you enter. To enter 2 to the power of 3, for example, type or click 2, choose the a to the power of b button, then type or click 3, and it will solve it for you. Next, we'll take a look at roots. So roots are kind of the opposite of exponents, but we can use them to solve each other. So finding the root of a number is the opposite of raising a number to an exponent. Therefore, you can use roots to solve equations involving exponents. For instance, what is the value of x in this equation? X to the power of 2 is equal to 81. What does this equation say? There is some number x that when multiplied by itself is 81. What number multiplied by itself is 81? Both 9 squared and negative 9 squared are equal to 81. So these are the roots. So consider the example on your screen. The root of 75 is equal to 25 times 3. If you break up the square root into two square roots, note that anything under the square root symbol can only be broken apart with multiplication or division. Then, if you can solve that, you can find the square root of 25. Finally, write the 5 next to the square root of 3 to represent the multiplication. The square root of 75 is equal to 5 root 3. That is the most reduced form. On the note of roots and exponents, we are next going to try rationalizing the denominator. In order for a fraction to be in its most simple form, there cannot be a root in the denominator of the fraction. So, after working a problem, if our solution was x over the square root of 2, you know that you are not allowed to have that root 2 in the denominator. So you need to get rid of it. In order to do this, you can multiply by root 2 over root 2 because any number divided by itself is 1. You aren't actually changing the value of your original fraction, you're just playing with its formatting. Then, just multiply across to get the simplified form, fraction. So this is what that looks like step by step. You begin with x over root 2, multiply that by root 2 over root 2. That gives us x times root 2, so x root 2, over 2 times 2, root 2 times root 2, which is equal to 2. Your new answer has the same value as the original, but it doesn't have a root in the denominator, that bottom number. So it's in its most simple form. Okay, let's talk very quickly about combining roots. So you can add or subtract square roots, but only when the numbers under the square root sign are the same. So in example 1, 4 times the root of x plus 2 times the root of x can be combined through addition because they are both attached to that root x, leaving us with 6 times root x. In example 2, same thing, but with subtraction. So 9 root x minus 3 root x is equal to 6 root x. Multiplication and division are more flexible. Different values can be combined under the root. So if we have root x times root y, we can combine all of that under a single root, leaving us with the root of x times y. Same with number 4, but we're looking at division. So root x over root y can be combined to give us the square root of x over y. Here are the buttons that will help us find the square root of various problems. So the original standard square root button looks like this. This takes the square root of numbers, variables, or terms that you enter after pressing that button. There's a second button that looks very similar, but it has an N in front of it. It's a bit more hidden. So in order to find it, you have to click on Functions and then scroll to the very bottom of the menu. The button takes the nth root of the number, variable, or term that you put under the root sign. To find the cube root of 27, for example, click the button first, then type or click 3, that's our cube, then find the right arrow or click under the root sign, then click or type 27. A brief note on working with fractional exponents. Think of a fractional exponent like a tree. The power is on top and the root is at the bottom. This is represented by power over root. Consider the following example. 9 to the power of 1 over 2. Notice that the exponent in this case is 1 over 2. That means 1 is the power, or the exponent, and 2 is the root. This is the way to symbolize a square root, so this expression is equivalent to root 9, or 3. What if you're given 64 to the power of 1 over 3? 64 to the power of 1 over 3 is equal to the cubed root of 64. Our final note in the Nonlinear Solving 101 section is on negative exponents. This has been summarized as follows. A number raised to a negative exponent can be written as a fraction with 1 in the numerator and the base raised to a power in the denominator. Here are two ways of approaching one exponent problem. X to the power of 2 over x to the power of 4 can be expanded to x times x over x times x times x times x. If we cancel out the same number of x's in both the numerator and denominator, which indicates division, we are left with 1 over x to the power of 2. This can be rewritten as x to the power of 2 minus 4, which leaves us with x to the power of negative 2. This means that 1 over x squared is equal to x to the power of negative 2. Another way to think about negative exponents is that they are a way to write reciprocals. This will also work if the negative exponent is the denominator of a fraction. Now you will have a bit of time to practice the lessons from Nonlinear Solving 101 before we go over a brief lesson on nonlinear solving.